so much. And we're going to look into that topic now in the upcoming panel. I'd like to ask Brigitte Vlaswinkel. Oh no, Brigitte Vlaswinkel will be connected to us online. And we have Aurélien Croq, who's going to join me on stage. Good morning. I'm just waiting for Brigitte. Is Brigitte with us? Yes, hello.
Yes,
good morning.
I'm with you.
Hello, can you hear us?
Yes, I can.
Brigitte, you're head of environment and sustainability at Dutch company Oceans of Energy. Good morning. Your technology, you told me earlier on that your technology floats like a water lily on the ocean. Tell us a bit more about that. How does it work?
Yeah, sure. Happy to be online. I hope everyone can hear me well. Yeah, it's quite exciting and maybe also a bit unconventional. Yeah, offshore solar is, of course, how we see it, a required addition to the existing renewable generation technologies because it solves the huge problem of lack of space onshore. And as you all know, solar PV is like a surface game. You need a lot of surface to capture the sunlight and make the energy. So our design at Oceans of Energy is kind of unique in three ways. And the first one is indeed that the solar system uses the sea surface to rest on, like a water lily. You know, water lily is quite large, capturing a lot of sunlight for photosynthesis. But therefore, it also needs to be light to float. And we took inspiration from this beautiful flower, and because we believe that the only way to make large-scale offshore solar in the end cost-effective is to design with the lowest possible material use. So not the traditional way trying to lift the infrastructure out of the water. No, our floaters, they float on the water surface. And therefore, they are very slim, flat, have low hydrodynamic loads. And the farm effectively moves like a blanket over the waves.
All right.
And
yeah, go ahead. Sorry.
And well, furthermore, like it's a very modular design. It's kind of like a Lego click and play. So therefore, it's highly scalable, which means you can easily scale up to very large solar fields. We're thinking of kilometer size solar fields, and that fast acceleration is really what is needed for those new innovations. And yeah, we've done now in 2 countries carry out a port assembly in the Netherlands and Belgium, and the rollout is fast. So the batches of the interconnector modules are with very light cranes put in the harbor, connected, towed out to sea, very light tugboats. So it enables very fast rollout, and that means it's also easily transported, installed, all across the world. And that is because it's very light, resembling a water lily in a way.
And you told me that you had tested a 1 megawatt device off the Dutch coast for 4 years, and there's more to come, right?
Yes, maybe you can go back to the first slide, because that's the system. That's 12 kilometers offshore. That's the next slide, the first slide. This is, so this slide indeed, here you see the farm. That was our first test a few years ago. So that's 12 kilometers of the city of The Hague. And we are basically the only one in the world with a proven system. It's also certified by DNV and Bureau Veritas. And it's been operational 4 years in the high waves of the North Sea. And you saw the picture, you already gave it away. The second picture is from one of our images of the farm in the storm. If you can go to that slide. There, this is in a storm from last year. This one, indeed. So we've seen about 10 storms, named storms, seen waves up to 10 meters high. This were waves about 6 meters high. And what you're seeing is basically that the farm is, it's basically getting a lot of slamming. You have to imagine, though, that this is kind of still a small farm. And as the island gets bigger, the slamming will, of course, happen on the outer side, but on the inner side, it won't happen. Right. But anyway, other project, so we just installed the system in Belgium. Now we just started building in our own factory a new farm, and that's our first commercial contract for our launching customer Shell and Eneco. And next year we will get that solar farm grid connected in a wind park in the Dutch North Sea. It's called Hollandse Kust Noord. It's 20 kilometers offshore. And yeah, it's very excited. We're very excited that this will be a primeur. And it's all because of the Dutch government, actually, because they kind of put this in as innovation criteria. And 2 weeks ago, the latest wind park tender in the Netherlands was also awarded to another wind park developer, Vattenfall. And they are going to build 50 megawatt solar. And yeah, we hope to build that, of course, with Vattenfall. And together with Vattenfall and 40 partners in a project called Bamboo, we are working towards the next step. I told you that about that square kilometer. That's the next slide, because that system of 200 megawatts installed capacity. On the next slide, you see that it fits easily between 4 wind turbines in any wind park in the world. Can you go to the next slide?
We're trying. Oh. Does that work? Having well,
well, it doesn't matter.
I'm sorry, we can't find the right slide. But you just mentioned this project at Hollandse Kust Noord. I understand that's half a megawatt compared to 1 megawatt device that you've been testing off the Dutch coast. It's obviously smaller, but there are technical challenges, right? Because it is in the midst of an offshore wind farm.
Yeah, well, the farm that I showed you the picture of was not grid connected yet. So what is now going to happen, we hope to test that first in our Belgian project before this commercial project. But so the grid connection of the dynamic power cable that needs to survive in a pretty tough sea, because the North Sea is a very shallow sea, thereby making it quite difficult to have dynamic export cable survive. So that is the biggest technical difficulty that we still need to achieve, and with that, it's Shell looking over our shoulders, making sure that this is up to the highest safety standards is kind of like a blessing, because together we are really tackling these challenges. So very happy with the collaboration.
And as you mentioned, that would be the next step to further project. You mentioned the 50 megawatt project plans for 200 megawatts. How tricky will it be to scale up that much?
Yeah, well, what we're seeing offshore and also in our numerical simulations is that the bigger we go, technically, the easier it gets, because the loads are just getting less. Of course, what will be tricky to scale up is other non-technical issues. Of course, we still need some changes to the electricity law in the Netherlands. Some changes are being made, but still something needs to happen on the governance level. On the other hand, we of course need to bring the entire supply chain with us. Now we are working with a solar panel that doesn't have a certification sticker yet of offshore proof this will survive 25 years at sea. So we kind of need to also bring on board the PV suppliers, all of the electrical components, to make sure that they can also withstand for a lifetime the harder conditions at sea. And these will also need to come in time, because we believe we can really go very fast. In the wind park tenders for the Netherlands, it went from 0.5 megawatt, that's the one we're building now. The next wind park tender asked for 5 megawatts for offshore solar, and now the new one is 50. Well, the next one is coming up, and I bet you it's going to be 500 megawatts. So this is going to go really fast, and the supply chain also needs to become on board. So that's kind of like a shout out to those parties.
Yeah, so lots of exciting developments ahead. Thank you very much, Brigitte Vlaswinkel. With us is also Aurélien Croq. Hello.
Hi.
You're the CEO of France's Solar in Blue. You were here last year, but not everybody of you were. So could you just explain how your technology works? It's a bit different from what we just heard.
Yeah, sure. So I'd like maybe to build on what Brigitte said and the brilliant introduction from Antoine. Definitely, we are lacking space to develop solar at very large scale. So we're basically designing a technology that enables to deploy solar at sea in very harsh conditions. So I think we've got all in mind the hard waves that we can get. We can get waves of more than 10 meters, especially when we are putting solar inside offshore wind farms. We have winds over 200 kilometers when we are looking at deploying for islands, for example, be it in the Caribbean, be it in Asia. And we also have to make sure, and I think that's the biggest part of the challenge, is to make sure that we are building something that will last for 30 years. So the big challenge for us is to make sure that even if we have 20 years in a row, 10-meter waves during several days each year, we will sustain that, and both the structure and the solar panels. So definitely what we need to do if we want to achieve a long lifetime and be aligned with our ecological goals is to lift the solar panels, because solar panels, you know, they can sustain very high temperature variations during the day, they can endure the sand, they can endure a lot of things, but what they don't like is mechanical stress. They don't like to have huge waves striking the panels, slamming the panels, and creating micro cracks. We're all aware of the problem of micro cracks, which will decrease your production, and then you end up after 10 years with a farm that does not produce anything. So to prevent that from happening, we are lifting the panels. But the idea is that we don't want to lift them 10 meters high, right? Otherwise, the economics are not going to fit. So what we achieved is to have a structure that is surfing the waves and lifting the panels just enough to prevent them from colliding and being slammed by the waves. So this is Sunset, the very first offshore solar farm in France and in the whole Mediterranean Sea. We deployed it last year. So last year I was here very happy to announce that we had deployed it and that we would get some nice results on our technology. And this year, I'll be happy to explain why our technology has made its proof and why our design is in the best position to win the competition in terms of lifetime.
Because you did some test runs, right?
Yes.
Tell us about that.
Yes, definitely. So thanks to the support of the French government and the Région Occitanie, we were able to put this offshore demonstrator last year, and we've got now a bit more than a year of experience at sea. So we got 8-meter waves, and I can tell you that we are very happy that we lifted a bit the panels. Otherwise, I'm sure that they would still be here, but micro-cracked and whatever you want. So we are very happy with the results we got in terms of mechanical resistance. This is a picture, so of course 8-meter waves occurs at night, so for drone views it's less convenient. So what you have here is just 2 to 3 meter waves in February, but we got a 50-year return wave in March. And we also were able to demonstrate the PV production. So we must not forget that there is a technical challenge to be at sea for 30 years, but first of all, of course, we need to produce electricity and make sure that this electricity is competitive. And what I'm very happy to announce after a bit more than 1 year is that we are able to demonstrate that using bifacial panels that get, you know, the direct sunlight and also the reflected sunlight, we are able to demonstrate 6% more production offshore than onshore. So it's really a great result in terms of economics and why going at sea. It's because we can also get more electricity from the same solar panels. And I'd like to insist on that. We are able to use mainstream bifacial glass solar panels. So it means that we don't need, you know, to reinvent solar panels to be fully waterproof, etc., etc. We can rely on current mainstream, very large-scale produced solar panels.
And this is just the beginning, right? You've got other projects coming up in France and elsewhere.
Sure. So it's a little bit in two steps for us. So first of all, I'd like to thank the French government for a huge support that they brought us 1 week ago. That's a 6 million funding for our next project, Megaset, which is the extension of Sunset, which you've seen in the slide before, extending to 1 megaset. And we are doing this project in collaboration with Technip Energy. Many of you know it's a very large French EPC, and they are helping us with the offshore operations. And we are also including in that project, for sure, demonstrating our technology. That's the key goal. But we are also including universities. University of Montpellier, they have a huge expertise in terms of dynamic cable. We've talked about the challenges of having a dynamic cable specifically for floating solar. And we are also including Sorbonne University. Many of you know them, and they have oceanographic observatories, and they will help us assess and mitigate the environmental impact of our structure. On that, I would like really to highlight the experience that we have for floating solar on lakes. As you know, floating solar on lakes darkens, the whole lake, and sometimes kills the ecosystem. Definitely, we don't want to reproduce that at sea. So that's why, again, lifting, for example, a bit the panels will allow more light to go to the ecosystem. We let 30 to 40% of the light go to the ecosystems, and we also allow all biological exchanges at the interface between atmosphere and the sea. So we are really shooting for the lowest environmental impact. And even in some remote geographies, we think that the shading that we provide can help, for example, preserve corals from whitening. So this is really the next step for us, 1 megawatt to be done by 2025. Of course, producing some electricity and being connected to the port of Sète, which has huge objective in terms of decarbonation. And that's what we're working on right now. But of course, this is one project to reach out for far bigger perspectives and 3 global markets. So you've understood that the blue economy needs to decarbonize shipping and industries located in port areas. So that's a market that we're addressing, and addressing it, for example, in Sète. We're looking at islands, so be it the French Caribbean, between Southeast Asia, where the first projects are coming in, because they have huge land use constraints, right? And they are importing oil, and they need a solution to be deployed quickly. And that's what we provide. And we've discussed it already, but of course the biggest market is for offshore wind and solar co-location. So definitely the Netherlands have taken a step ahead in the political commitments towards the deployment of offshore solar in co-location with offshore wind. They have an objective of 3 gigawatts by 2030. They have a 50 megawatt tender that was won by Vattenfall, and they will select the technology that they will use by 2025. So of course that's a perspective. But Malta has done the same. As you know, Malta, they have lots of wind, great irradiance, and what they want to do is put both offshore wind and offshore solar together. They opened a tender for 50 megawatts. So I think it shows that it's just not the Netherlands, going on their side. It's really throughout Europe. Italy, there's more than 200 megawatts greenfield projects being developed, associating solar and offshore wind. So also great market perspective, and also showing that the awareness about offshore solar is really spreading pretty fast. And Greece has also committed to 10 pilot sites with a feed-in tariff for offshore solar. So I think that all this shows that there is a great market traction, great awareness from European political authorities. We have already the technology, the first step of the demonstration, support from our national government to go further and become a leader in the deployment of offshore solar. Thank you very much.
Thank you. Thank you very much, Aurélien Croq. Thank you, Brigitte Vlaswinkel, for talking to us from the Netherlands.